Hello, thanks for joining us for the Consulting Specifying Engineer webcast, Fire and Life Safety Detection Systems. I'm your host and moderator, Amara Rozgis with Consulting Specifying Engineer and CFE Media and Technology. I'll be with you today for this hour-long education session. Let's learn about this webcast platform. If you're having trouble with the slides or with the audio, refresh your browser or click on the Refresh Media button directly under the presenter's photo. You can control the volume settings by adjusting the volume on your own device. If you're having technical problems, click on the question mark at the top right corner of your screen to do some system checks. However, if you need an online technician, type a message into the Ask a Question box and we'll respond in the Answered Questions box. To download today's presentation, use the event resources at the left side of your screen. Please type questions for the presenters in the Ask a Question box on the left side of your screen. You can ask questions at any time during the presentation, and we will get to the Q&A portion in about 45 minutes. If you're interested in receiving one AIA CES approved learning unit or health, safety, and welfare unit for this event, you need to pass a 10-question exam. To take the learning unit exam and to download your AIA CES certificate, use the Learning Unit Exam tab at the top of your screen. The quiz will open in a new browser window, so I suggest you open it right now because the link will break when this webcast ends. In keeping with the American Institute of Architects Continuing Education System Policy, please take a moment to read the quality assurance slide. All right, so here are the learning objectives for today, and we'll talk about these during the presentation. Please note, if you see any blue underlined text, that's a hyperlink in the PDF where you can get more information. All right, well, we've lined up two really informed speakers. First off, Dave Lowry is Chief Fire Marshal with the City of Boulder Fire Rescue. Dave has been with Boulder Fire Rescue for more than 20 years. Before his appointment to the position of Fire Marshal, he served for 8 years as the department's fire protection engineer. He oversees the Life Safety Division, including code enforcement, building and construction, fire and life safety education, and fire investigations. Dave also has extensive experience in plan review, as well as inspecting and acceptance testing of fire protection systems. William Koffel is president of Koffel Associates, a fire protection engineering, design, and consulting firm, and he's recognized as an expert in the fire protection and life safety aspects of codes and standards. The firm provides consulting, engineering design, and construction administration, codes and standards development, product testing, evaluation, representation, and litigation support for public and private clients worldwide. Bill remains active in the development process of the industry's governing codes, standards, and design guidelines, including ICC, NFPA, SFPE, and UL. Both Dave and Bill are on the Consulting Specifying Engineer Editorial Advisory Board and are two of the most knowledgeable in the fire protection industry. All right, well, I'm eager to get started on this discussion, but first we want to ask for some audience input. So we have a quick survey here for you. The question is, what is your role in fire and life safety systems? And we'd like you to fill this out so we know exactly who we're speaking to and so that we better understand exactly how to target some of this information. So there are obviously quite a few choices here. If you could let us know who you are, we will then be able to ensure the information is appropriate for our audience. All right, so information is coming in and it looks like the vast majority of the audience is from an engineering background, however, not fire protection engineering. So it looks like, yeah, just about 2/3 of the audience are engineers, but not fire protection engineers. So with that, Dave, I'm going to turn this over to you.
Thanks, Amara. And appreciate everyone being here. That is great that we have you and we have the engineers on looking at fire alarm and wanting to kind of know more about fire alarm. So I'm going to do kind of a quick intro here, kind of giving the kind of the what, the where, and the why. And today's seminar is all about detection. So I'm going to kind of do an intro into the detection part of it as well. And then Bill will take over, then I'll come back, and then Bill again. So I think we've got it lined up. But the first question kind of comes in is, you know, what is the purpose of a fire alarm, right? And this what question of the purpose, I think if you keep that in mind, it allows a lot more of the fire alarm to be understood. And I know that may sound simplistic, but if you just kind of keep in the back of your head that, you know, the purpose of a fire alarm is to detect the presence of a fire, you know, in that building or that space, right? I mean, it doesn't have to be the entire building. So, so think about that. Instead of it just being, it's a have to, I have to install a fire alarm because the code tells me that I have to install a fire alarm. Think about that what the purpose of the fire alarm, that it's to detect a fire. Obviously it does have other purposes too, and we can exaggerate those or lessen those depending on the type of occupancy that we're talking about. We want to alert people within the building, or we want to alert certain people in the building depending on the type of signaling. We may want to signal emergency responders to respond to that location for that emergency. And then if you just go back and think about how long we've been doing this, from the time that we had someone walking the streets in New York City, ringing a bell to alert people and let those people know that a fire has occurred, and to alert emergency responders. That's how long we've been dealing with, quote, fire alarm type situations. So that's the what, the where. So the big distinction here is, where do we install a fire alarm system? And the easy answer is, well, where the code tells us to, right? I mean, that's kind of the go-to. Like, whatever the code tells us to, that's where we're going to install it. The code in those first few areas at the top of it, you know, we're talking about the actual codes that, you know, tells us where to do it. Something like the Life Safety Code, NFPA 101, NFPA 5000, their building code, can be the International Building Code, International Fire Code, NFPA 1, that fire code. Those codes are specific. What you do see out to the right in the slide there, that we put a picture of NFPA 72 there, National Fire Alarm and Signaling Code. Despite that name, it does not tell us where to put a fire alarm system, right? That particular document is a standard. It's a design and installation standard. So no place in there do you find where to install it. You find the design of the fire alarm, how to install it, and how to maintain that fire alarm system. And then never forget that you could be dealing in like specific occupancies, right? Like a specific situation, and we may have a standard out there. Take, for instance, maybe the NFPA 45, the standard for the fire protection of laboratories using chemicals. That particular standard may have specific requirements for detection with a fire alarm system associated with it. And then, you know, mechanical codes could also have those particular items as well. So we talked about the what, the where, but let's pause just a minute and talk about the why we're installing that. We typically say, well, why are we installing a fire alarm system? And think about the goals that we want to achieve with that fire alarm system, right? Typically, we always look at that and we say, well, it's life safety. Fire alarm is all about life safety. Yep, that's a good one, actually. That's a great one. And I think if you talk to most people out there, they're going to tell you that why do we install a fire alarm system? It's life safety of the building, right? To protect the people. It's not always the case, right? Property protection is also a reason that we install fire alarm systems. And there is nothing wrong with saying, I'm installing a fire alarm system for the protection of my property. Know that there's also subcategories under property protection, something like antiquities protection, heritage protection, like museums. You know, they're putting in for early notification of a fire to protect those artifacts within that building. And that's okay. It doesn't always have to be life safety, even though that is the majority of it. I would tell you that Bill's going to also talk a little bit about this. So with me talking about it, and then Bill also talking about it, you got to think it's pretty important to keep that why in the back of your head when you're looking at and wanting to kind of design and install that fire alarm system. But that also leads us into the webinar's main topic, which is detection, right? The detection elements of the fire alarm system. So I lead in with this particular slide saying, all right, so now we know that we have a fire alarm. We're going to install a fire alarm system. And so what do we need to consider when we're picking that detection? Right. And I listed like 8 factors on the slide here of what we want to consider on that particular area. We want to talk about, well, we talked about number 1, the goals, the objectives, the life safety, property protection, mission continuity, heritage protection, whatever that may be. Right. What about the type of fire? Right? What type of fire are you expecting in the building or in that space that you're protecting with that detection? You know, is it a slow moving fire, or is it a fast moving fire? Is it a slow building fire, smoldering, thick smoke, or is it like a flammable liquids fire that goes from ignition to complete combustion instantly in that particular situation? One of those two, right? So keep in mind that the type of fire can also dictate the type of detection that you're going to pick. What about the occupancy or the use of the building? Well, it also kind of ties in to that goals and objective as well. But then that number 4, 5, and 6 that I listed up there, the ceiling height, ceiling construction and configuration, as well as the ambient conditions that can be expected in that particular space or building. Don't discount those, right? Always keep those in mind because that's going to really dictate the detection and the effectiveness of that detection, as well as you obviously also have limitations to the detectors as well as installation requirements. So when we start talking about all that, then we kind of go to, well, what are my choices of detection, right? What are we talking about? Well, we know we have smoke detection. We also have heat detectors. And then we also have like radiant energy sensing detectors. And I'm going to stop right there for just a minute and kind of point out that all 3 of those detection devices are really detecting what we refer to as a signature of the fire, right? We're either detecting like the smoke that the fire produces, whether it's visible smoke or invisible smoke, the heat that the fire detects, or the light that the fire is emitting off, right? Somewhere in there, we're looking at those type of detection to look at that signature of that particular fire. We also have other detectors like the flow of water in our water-based fire suppression systems. And then we also have manually actuated fire detectors, right? Which is not to be dismissed, right? The code actually requires manual actuated in quite a few occupancies. However, they can also be used for specific certain requirements. Like if we're wanting to do certain occupancies, think about like a maybe an institutional type occupancy, whether it's a jail or a prison, or whether it is a assisted living, full-fledged nursing home, that they get the private notification in, and to actuate full notification, maybe that controller has a manual alarm system that they want to actuate in that sense, right? So we want to look at these specific type of detection, pick the correct one, and by all means, consider those other items that I talked about, because one of the goals of this fire alarm system is to not have those false fire alarms, alarms, right? We don't want it to activate unless it needs to activate, right? And we're going to do that with the proper design. We're going to do that with the proper installation. And then one of the most important things is the inspection, the testing, and then maintaining that fire alarm system as well to help with those reduction of false fire alarms. Amara, I think you have another question here.
I sure do. All right. So our next poll is taking a look at what kind of buildings the audience works in. So we want to know, there's quite a list here. Which building do you specify or design or work in the most? So we only want you to select one. And we're looking for the buildings. These are all commercial buildings. These are all, well, we've got a couple that include non-residential living spaces. But let's see here. So thank you for your responses. It looks like thus far, the winners are, hospitals and healthcare buildings, not too surprising, and industrial, manufacturing, process buildings. And then let's see here. Third place is K through 12 schools. So we're working with folks from a wide variety of building types. So thank you so much for those responses. And I will turn this back over to you, Bill.
Thank you, Amara, and thank you, Dave. Before I go into expanding on goals and objectives that Dave talked about, I want to go back to one of his early comments about fire alarm systems being an afterthought. And it kind of reminded me of some work that we had done for the fire alarm industry quite a few years ago. And my message to them at the time was, yes, fire alarm systems are often an afterthought. We do inspections or surveys as buildings are getting ready for occupancy. And clearly, one of the last things that's often being done is getting the fire alarm system installed and getting it ready for acceptance test. But for the designers, and I know we have a lot of engineers and designers participating in this program, I want to encourage you to think about the full capability of the fire alarm system. And yes, we're going to focus on detection here today, but there is a lot of information that modern fire alarm systems are already collecting. There is a lot of information that with some enhancements in terms of our initiating devices, fire alarm systems could collect. And then we can process that information and think about the advantages and benefits that we would have if we use some of that information to incorporate into our overall design. So having said that, let me go back to Dave's comments about goals and objectives. In the fire protection world, we tend to think of 5 typical goals that I might consider as a design professional. Dave talked about life safety. He talked about property protection. He mentioned mission continuity or continuity of operations. And those are the 3 that I will focus on in this part of the presentation as well. The other 2, however, deal with preservation of cultural resources, which clearly could have a detection consideration. And then the last tends to be environmental. And that may have, of the 5 that I've mentioned, maybe the least consideration to detection might be far more oriented towards suppression and suppression technology. But what I want to encourage the designers to do is think outside the box a little bit. Dave gave us a great background on the codes and the various codes and standards that I might need to refer to, whether it's the International Building Code or it's NFPA, we mentioned NFPA 45 or NFPA 75 for data centers that will have additional fire alarm and detection requirements in it. But have we ever thought about sitting down with our client, the owner, and asking them some fundamental questions? What is it that you want your fire alarm system to do? What would be an acceptable outcome if you had a fire in your building? And if you can get them to answer some of those questions, that might lead you down a path that not only complies with the code, but now goes above and beyond the code. So NFPA has a document, it's a guide, NFPA 550. I recall quite a few years ago where NFPA was considering getting rid of NFPA 550 because nobody uses it because we don't get any public inputs or public comments on the document. Well, that doesn't necessarily really correlate the use of a document. It's just that this document being a fire safety concepts tree, there's probably not a lot to change about it if the committee got it right in the beginning. So if we look at the top of the tree, it talks about defining our fire safety objectives. And then there's an OR gate that says we either prevent the fire or we manage fire impact. Well, I would offer that while that's an OR gate, that's only an OR gate if you are 100% effective at preventing a fire or managing the fire impact. And in reality, there are some probabilities that I might assign for that on a particular, we have some industrial folks in the presentation in an industrial facility that yes, there are certain fires that I can prevent with hot work permits and inspections and safety protocols, et cetera, but we're still likely to have some fires. And now how do I manage that fire impact? So that's NFPA 550. I've also used this not just in design, I've used it post-incident to look at what really went wrong and what were some of the more significant factors with respect to the loss that occurred. So I'm going to go back and revisit Dave's presentation in terms of goals. And the life safety goal for most people would say the various codes, and I know I use some older editions there, and I do that for a point, and that is, first off, make sure you have the correct, appropriate edition of the code for that jurisdiction. And then as a design professional, because remember, our standard of care goes beyond just minimum code compliance, it might be appropriate to look at some newer editions of the code. So we have some healthcare folks, and they reference the 2012 edition of the Life Safety Code. And that's what the Center for Medicare and Medicaid Services is going to enforce. However, I might be required by a local jurisdiction to comply with a more recent edition, or I just might want to look at a newer edition to see if it deals with things differently and maybe in a way that offers a better level of protection or maybe a more cost-effective level of protection. So from a life safety perspective, I think the codes do a pretty good job of that, except maybe emergency response personnel. And I know that it's within the scope of the ICC Performance Code, but I'm not convinced that the codes really look at first responder safety in developing a lot of our prescriptive code requirements. Dave mentioned property protection. So property protection is included within the codes, but in many instances, it's at a much larger scale. You know, the scope statement will talk about the safety from a public welfare perspective. If I have a very expensive piece of equipment, or if I have a warehouse and I am the sole warehouse for this company, if we lose that product in the warehouse, what's the impact on our ability to continue to operate? And that really gets me into mission continuity. But the point is, I could have some pretty expensive pieces of equipment or materials within that warehouse. So I'm going to encourage you to think a little bit beyond the minimum prescriptive code requirement when it comes to property protection. And again, maybe our client, the owner, the developer, might be able to ask some questions. Well, what would be an acceptable fire? And I'm going to, again, go back to my storage occupancy. Many storage occupancies are protected with a sprinkler system. The criteria for the design of that sprinkler system, the design criteria that's in NFPA 13, are based upon 3 criteria for that rack storage arrangement that we see. 1, we maintain structural stability. 2, the fire doesn't spread the length of the aisle or the row, the rack. And then 3, the fire doesn't jump across that aisle. Now, nowhere in there does it say, Mr. Owner, you might lose everything in this warehouse because of soot damage. That's something that we should probably discuss with the owner. And to me, that's the advantage of performance-based codes as compared to prescriptive codes, because we tend to have those types of discussions because the owners are part of the team that's going to be developing that performance-based design. So Dave mentioned business continuity. You know, many insurance carriers will tell you that some of their more significant losses today are not direct property damage, but the loss of the continuity of that business operation. You know, think about a data center. I have that listed on the slide. And we've done work for credit card processing facilities. If I go into a store after this is over and I want to buy something and I pull out my credit card and it's denied, not because of my credit, but because that data center is not functional, what are my options? Well, option one is I choose a different credit card. So it goes to a different company, different processor now. That company that lost that transaction is not going to recover that income. Or maybe I carry cash around and I pay for it in cash. Or three, I leave and I might come back later and process that transaction. There's a significant loss of revenue that could occur if that data center is out of operation. And I could also look at the warehouse operations in my own office. We're a consulting firm. What am I most concerned about with a fire in our office? Well, I hope my employees are awake and alert. We have fast response sprinklers throughout the office. What about that server? Yes, we have backup, but is the backup the same as the primary? So yes, I have an additional level of detection to protect that particular piece of equipment. Now, many times we'll look at this from a risk analysis perspective, where we want to try to identify what the risk is, and we'll look at various scenarios and we'll identify the outcome, the consequence of that event occurring. We'll look at the likelihood of that event occurring. And now I can present to the owner, well, here's some scenarios we should look at, and is that level acceptable? Or is that outcome acceptable? Now, in a perfect world, this would be quantitative. I'd have probability numbers or frequency numbers that I could plug into this analysis, and I'd have this fault tree or event tree analysis. But many times we have to look at more of a qualitative risk assessment. And here's a fairly simple risk analysis matrix. Those of you in healthcare, you know the Joint Commission, if you're accredited by the Joint Commission, they use a very similar matrix to identify the risk associated with the deficiencies they've identified in your facility. So I'm looking at what's the potential consequence. I'm looking at the outcome that might occur, the frequency that it'll occur, and then I can determine if that risk is acceptable or not. So with that, I'm going to transition now back to Dave, and he's going to talk about the documentation and primarily what he as a regulator expects from those of us that are designing systems. Dave?
Yes, sir. So we are going to talk a little bit about, I mean, one of the objectives of this webinar was, what is the documentation that needs to be submitted if you have to submit plans, right, for permit or approval? And it's not the most flashiest thing in a fire alarm. It's kind of more of a chore almost, but ultimately it's also not that complicated, I guess is the way I would say it, right? I know it can get very technical, but one of the number one questions that I always get is like, hey, I've got to install a fire alarm system, right? Whether it's mandated by code or whether you're doing it for life safety or property protection, mission continuity, right? We've talked about that, but you have to do it one way or the other. You've chosen to do it. So I get the phone call and it says, what do you need from me, right? From the designer, from the engineer, from the owner even, or the project manager, which some of you may be. Looking back at the first survey, a poll question, a lot of you are engineers, not necessarily the fire protection type. And that means that some of you guys may be helping with the design or designing and or project managing this, right? So what do you need to do? And again, do you have a checklist? Do you have a form? Yes. I do. But I haven't updated my plan submittal form in years and years, because in 2013 edition of NFPA 72, we added Chapter 7 to that particular document, right? And Chapter 7 is just simply titled Documentation, is where we took all the documentation requirements and we consolidated it in a specific chapter on there. So here's part of Chapter 7. There are more sections. It goes 7.5 and 7.6 as well. Don't think it stops at 7.4, but this is what's pertinent to today's webinar, right? So when we start looking at this, you can think of it as what does Chapter 7 apply to? What are the minimum requirements of documentation that I have to submit? What about the design layout? What do I need to include with that design layout? And if I am having to submit shop drawings, what do those shop drawings need to have on there, right? So if we just kind of look at this and you go down it, and realistically, if you had NFPA 72 and you had it open, this is something that you would see, right? In the minimum requirements. Well, back up just a second and make sure you understand that the application of Chapter 7, you have a little bit more, but you have two main bullet points up there. One of them says that it applies to new fire alarm systems. And then the next section down also says that it applies to existing fire alarms. I don't think it uses that word, but it says fire alarms that are being altered or renovated or additions to, right? So anytime that you're working on or adding to or modifying that fire alarm, this documentation chapter does apply. So then we get into that 7.2, which is minimum required documentations. And just make sure you understand, this is the minimum, right, that you have to submit when it is required that you submit documentation, right? So 7.2 is kind of that non-negotiable, everything that's applicable to your design, it should be listed here. So when you start looking at that particular section, going down there, know that I think there are like 17 bullet points on there, right? And then if you really read through there, 11 of those bullet points or numberings of what it is specific to the submittal of plans for the review, the approval, or the permitting that has to be on the plans, right? That has to be on the plans. And then there are 6 items in that kind of a numbering that are mandatory documentation at the completion of the system, right? That needs to be present, like either at that acceptance test or at some agreed point, right? And so we're looking at that and saying, that's something like the record of completion, the as-built drawings, right? The manufacturer's instructions and maintenance documents, items like that. So, and then there's some sub bullets in there. So I think when you add it all up, what I put on there was I think there's 21 items that are mandatory if you have to submit it, right? These are the minimum items that you have to put on those plans. So when you say, what are you requiring? I'm going to refer you to Chapter 7 of NFPA 72 these days, right? I'm not really going to say, well, here's Boulder Fire Rescue's plan submittal sheet. Quite honestly, I don't think I need to retype that because it's in the document that I have adopted here in my area. So with that, and we're not, and just so you know, all of a sudden I have on the slide 7.2.1 paren 1, meaning it's the very first item. We're not going through all 17 items at all. This is just a summary, right, of going through there. But the very first item says that you need a written narrative talking about the intent and the system description, right? Understand from the start that who you're submitting these documents to, whether it's someone like myself or whether it's an insurance AHJ, or maybe it's even the owner themselves of this particular building or space, right? We don't necessarily have that knowledge that you as the engineer, the designer, of this system have, right? We haven't been planning and working on it and talking to the architect and the other engineers that are working on this particular job, right? So this scope of work, this written narrative becomes extremely, extremely important in that sense that the more that you can explain what your intent of putting this fire alarm system is, talking about that why also that Bill and I have been talking about, the better off it just starts the plan review off in a positive manner, right? If all I have on there is that we're installing a new fire alarm system. Okay, well, that is a written narrative, right? It is a sentence that lets me know what you're doing. But any type of elaboration is going to be helpful in that plan review. So just take some time I always tell people, take some time and put a detailed written narrative in there. I cannot speak for all the plan reviewers out there. I have personally never rejected a set of plans for having a too lengthy narrative. Just me, maybe, but I doubt that's going to happen very often as you go through there. And then we start talking about, 7.2, that's the minimum. 7.3 only kicks in when it's required, right? It starts out, it says where required. So there's going to be some section that basically says you're required to supply some type of system design layout documentation, okay? And that is, and it goes through a long sentence of where required, other governing codes, laws, standards, something like that. But the important part also, it says, or other parts of this code. And what I mean by that in this slide is when it says other parts of this code, that's NFPA 72 that we're talking about. So you can put kind of an example down. When you look down into that section and we talk about detection, which is what we are talking about today, and I just randomly picked like smoke sensing fire detectors because that is a very common detection out there. It states that smoke detection design documentation shall be provided in accordance with section 17.7, which is the detection chapter, and 0.7 in that is smoke detection, right? Well, that particular section, which is the other part of the code, specifically says that the designer has to list the performance objectives of that detection device or that smoke detection device, right? So it is, so even though that 7.3 is not listed in the minimum, it's where required. Other parts of this code does require it, right? Does require it. And this is just one small example that it is basically now becomes part of that minimum that you have to submit. So if you are doing a smoke detection layout, then at some point in time, whether it's in the written narrative or another part, something needs to be listed saying that we're installing the smoke detection in the prescriptive manner listed in 17.7, or you're doing a performance base and you're going to list those objectives, right? Is kind of where is what I'm getting at, is a little more information on that. And then the last part are shop drawings required, right? And once again, it goes down to where required. So it's not essentially mandated on this, but yes, I'm going to require you to submit shop drawings. Most jurisdictions are going to require some type of shop drawings if they're going to issue a permit, right? If they're going to be issuing a permit. Something like NFPA 1 or the International Fire Code mandates that you submit drawings for permit, right? And so when you look in section 7.4, then you run through approximately 40 to 50 items that you have to include on those shop drawings, depending on how you count, right? Between sub-bullets and not sub-bullets is the reason I kind of put that rough number in there. Keep in mind that a lot of those requirements are a repeat of what's already from 7.2 and 7.3. So it's not like an additional 50 or 40 or 50 items, right? They are some repeats on there, but there's my list, right? You know, what do I need? I need the requirements that are applicable to your fire alarm system out of 7.4. that is my plan review submittal documentation that when I'm asked, I look at. And so when I wrap up this particular section, and before I turn it back over to Bill to kind of wrap up these slides, I want you to keep in mind, just remember, the local authority having jurisdiction or plan reviewer, we don't have that background knowledge or the details that you have on this particular design. So that written narrative becomes very important. And once again, you can never have too much detail, in my opinion, in that particular one. Likewise, extra information on the plans, once again, maybe it's me, but I've never rejected a plan for having too much information on a set of plans or extra information on a plans. I just don't think you're going to get a return or a rejection, right? But it does need to be relative to the system. And what I'm saying there is like cut and paste. If you're the designer, that's perfectly fine. I mean, I would do it, right? But it needs to be relevant to the job. It can't just be a cut and paste blanket general notes for every particular one. So when I'm looking at this, I'm saying, wow, they're talking about, heat detection, but yet they have no heat detection shown on the plans. When I ask about it, they're like, oh yeah, that's just a generic comment. And I'm like, well, it's not applicable to your plans, right? So yeah, I don't mind cutting and pasting, but you need to kind of look through that and then delete what's not relevant. And then certainly add anything unique about that drawing that you know about that we don't know about, right? That's kind of where I reside in that. So just kind of keep all that in mind. I think you'll be okay. Bill, I'll let you take it from here.
Thanks, Dave. And I'm kind of bring this whole thing to conclusion now as to what we do at the end of the project in terms of acceptance testing and commissioning, and then also to just in a few minutes look at a couple of case studies. So I introduced this concept of commissioning. And the concept is that at the end of the project, we probably want to answer the question, did the owner get what they wanted? And did the owner get what they paid for? So remember, the acceptance test protocol in NFPA 72 addresses the fire alarm side of things. So if my sequence of operations says a smoke detector or a heat detector or radiant energy detector is supposed to do something, in addition to sending or resulting in an alarm signal, it's going to have some control functions. The NFPA 72 tests the fire alarm portion of that. So we're going to test to the relay or the control module. Commissioning is end-to-end testing that I'm going to make sure those elevators recall or whatever is supposed to happen when that initiating device senses a condition. So NFPA has two documents that I'm going to make quick reference to. NFPA 3 is a standard on commissioning. It's not a technical document. This document basically talks about a process, the commissioning process, and how we should go about it. And by the way, commissioning doesn't start towards the end of the project. Commissioning actually should start at the very beginning. And part of this will be to develop a test plan, not just for the initial commissioning, but also at what frequency do we need to reevaluate whether this system is operating in its entirety. Again, contractor comes in, does the NFPA 72 test. Doesn't necessarily verify, nor do they need to verify that the elevators will recall, doors will close, all those types of things. They're testing the fire alarm side of things. So today, a lot of our systems are integrated systems. And that's the reason for commissioning. And NFPA has a second relatively new document, which is a standard for testing integrated fire protection and life safety systems. So this tells me how to test that communication link between my fire alarm system and my building management system or my security system or whatever those other systems are. Today, integrated system testing is required for certain new buildings. If I'm looking at 2018 editions of the codes, but also we have to recognize that part of this is testing of existing systems. And the codes will give us a default. But notice it says the default is you test it every 10 years. NFPA 4 actually has a more frequent test period, unless specified by an integrated system test plan prepared in accordance with NFPA 4. So if in the beginning I develop this test plan and I say, based upon this occupancy, et cetera, this system needs to be tested every 7 years or every 15 years, if that's approved by the authority having jurisdiction, that becomes my test plan. I encourage design professionals to think about incorporating commissioning and integrated system testing in their contract documents, even if it's not required by the applicable code. Okay. Again, I mentioned that NFPA 4 has a 5-year period. The codes have generally extended that out to a 10-year period, but they both reference an integrated system test plan that was developed typically by the design professional for that system. Okay, so now I want to look at some case studies, and this kind of highlights some of the things we're going to be talking about in some of these case studies. I'm going to go through this fairly quickly. This particular case study is a healthcare facility. It's a 20-story healthcare facility. It's located in the Middle East. We had a lot of detection, or I should say we didn't design this. There was a lot of detection in this building. One of the things we found, not so much with detectors, because they're addressable and it's fairly easy to correct, but there were other initiating devices like water flow alarms that were not coordinated with the smoke compartments in that healthcare facility. So when they wanted to implement an emergency plan that called for certain things by smoke compartment, it was a rather expensive change after this system was installed to be able to meet the owner's needs. So again, to have that dialogue with the owner up front. Smoke detection for air handling systems, the last bullet on this slide. Who's taking care of that? Is there a fire protection engineer on the project? Is it a double E and an ME? Have we coordinated our designs? You know, who's verifying that it actually gets done at the end of the day? We had 25 people die in a hospital fire in Saudi Arabia. One of the factors was that the air handling system, which happened to be a plenum system, did not shut down by detection of smoke. They talked about different types of detectors and the need to identify detectors that are appropriate for the fire, but also appropriate for the environment. So this is a environmental services closet in a healthcare facility, again, not in the US. You can see that there is a detector towards the back of the room right above where they go in and they fill buckets with hot water. The hot water there is a little hotter than it is here in the US. The door is typically closed. They generate steam, and they were getting nuisance alarms. So that smoke detector, the location wasn't appropriate. Maybe smoke detection isn't the right technology. Maybe heat detection would have been better. Of course, we do have a sprinkler in the room, and there's a question that talks about sprinklers and detection. There is a sprinkler in the room, so I already have a form of heat detection. So maybe this is a space that we didn't need an additional detection device. And I'm going to turn it back to Amara, who's going to talk about AIA learning units and then get us into our question and answer period. Amara?
Exactly. Yeah. Thank you so much, Bill and Dave. Thank you. That is a lot of information. As a reminder, you can earn one AIA learning unit for this by passing a 10-question exam. I also want to remind you that you can ask a question at any time of our two presenters. So Dave and Bill are willing and able to answer questions. So type your question into the Ask a Question box with the presenter's name before the question so that I know who should answer it. And last but not least, you can download these presentation slides in the Event Resources tab on the left side of your screen. All right, here we go. Bill, I'm going to send this first question to you. This is kind of a long question. So who exactly should be designing and specifying a fire alarm system. So we have options like fire system technicians, not a professional engineer. Does it need to be stamped by a professional engineer? Can you go into background on all of that kind of design aspect?
Sure. And I know it's a long question. It's a very simple answer. It depends. And seriously, I can't give you one universal answer. I can give you some resources to go to determine what is required, what is recommended. So some state boards do define the design of a fire protection system as the practice of engineering. And that would require a professional engineer to design the system. Now, there is a distinction between design and layout, or Dave referred to design drawings and shop drawings or working drawings. So quite often, as a design professional, I will design the system and I'm making decisions, or I'm answering those questions that Dave asked up front. What type of detection am I using? What's appropriate for the occupancy? What should this system be doing? Okay. I then those construction documents are then taken by the contractor who has been awarded the project to install this fire alarm system, and they're doing the detailed layout because they know exactly what manufacturer they're going to be using and so forth. So personally, I think there's a distinction between design by an engineer versus the actual layout. Now, some projects might be more simple. I refer to my office building, 4-story office building, all office occupancy or business occupancy, not a complicated project. You know, a fire alarm contractor could conceivably design and lay out the fire alarm system. I turn that into a 42-story high rise with different occupancies and smoke control, stair pressurization. Now I'm looking at integrated systems. I think it's more of an engineering function. Some states will allow contractors with a certain license, California, for example, to design this system. So first, check what's required in your jurisdiction. Then I would answer the question of how complex the system is. And for the contractors who do design work, I would offer some same guidance that I offered on a call earlier this week to some sprinkler contractors. If you're going to do design, then you are assuming the liability of the design professional. So, Amara, I want to give time for some other questions as well.
Yeah, so your answer of it depends really makes sense here. Thank you. All right, Dave, this next question is for you. Would early warning detection or air sampling be considered spot type or line type detection?
I wanted to say it depends, but that one I can't say that on, right? Because most of these, Bill's right, it depends, but not that one. So I consider it spot type for me personally, right? Because the air sampling part of that detector is located in that area, and we're relying every bit on that dynamics of that fire, right? The smoke, the hot gas, to move that smoke to that air sampling port. Once it gets there, then it travels through that air sampling tube to the detector, right? So when we lay out a air sampling type smoke detection, we're still using the same principles as we do with spot type detection to put all those ports in the ceiling or subfloor or wherever that may be going. So I look at it certainly as spot type detection.
All right, very good. Thank you. Bill, the next question is for you. Smoke detection. How often does smoke detection installed in plenum space? So we're talking about the tools involved here, the HVAC ductwork, all of that kind of stuff.
Again, great question. And let me preface my response by saying that NFPA 72 requires that I need to have access to any initiating device that I install in the system. So if I'm going to put spot type detectors in a plenum space, there has to be access to test that system. Now, there are smoke detectors that can be tested remotely. And that may be a design option that I choose. Let's see. We talked about, oops, the question disappeared on me now. The question goes on to talk about, so the type of detector. Do I use a spot type, traditional spot type detector? Or do I use air sampling? Do I use duct detectors that have sampling tubes into the ductwork? Those are decisions I'm going to make as a design professional, and part of my decision will be who has to maintain it and what access do they have to maintain that system. When we do a design, I often encourage our client to have, if they've already identified who's doing inspection, test, and maintenance, have them review our design. I'd like those questions answered up front. Have I put something out there that can't be adequately tested? So there are instances where smoke detectors may be in a plenum space. If they are, they need to have access. The subfloor for the data center, typically they lift the floor tile to get access to that smoke detector to test it. So I think I've answered most of Mr. Williams' question.
All right, very good. Thank you. Dave, this is the next one. This is definitely for you. What do you find are the biggest holes that engineers forget in the permit submission process?
Yeah. Well, that's a broad question, but yeah, honestly, it's the lack of detail, right? It's that when I was talking about that written narrative or scope of work or however you want to word it, I find that I simply don't have the information to know how to review this set of drawings, right? And what I mean by that is, like, when I say that, like, if I don't know how to start because I don't understand what you're doing, it doesn't really matter what's on the next few pages of your plan, right? Because I don't know how to review it if I don't understand what you're doing. So I would say the lack of detail and listen, kind of what I was saying, I understand 100% that you have all of this information about this plan, and you've been working on this building or something for, months, at a minimum, several months, right? And so what's kind of instinctual to you when you start laying this out or directing a designer to lay it out seems like just, oh, that's common knowledge, but it's not for us, right? It's not for us. And then the other thing is just kind of what I would say is lack of detail, right? And lack of a review of the drawings after they've been done. And, just for simple, honest mistakes that were done on there is just a lack of detail.
Sure. Okay. Thanks for those insights.
Mm-hmm.
Bill, the next question is a codes question. IBC codes are often interpreted as not needing smoke detection if fully sprinklered. Can you comment on that? How does that play into the comprehensive goals for fire protection engineers?
So that's a great example of why I'm encouraging you to think about the owner's goals and objectives. So the code perspective, depending upon the occupancy, if the code assumes that the occupants are awake and alert, the code generally assumes that the occupant is likely to detect the fire, maybe even before a detection device would detect that fire. And the sprinkler, in particular, it's a fast response sprinkler, is likely to respond in time that we will have adequate egress at time for that building. So that's kind of the underlying concept. And I will say that's somewhat of a U.S. perspective. I get outside the U.S., I see a lot of sprinkler buildings with smoke detectors. Remember, I said it's occupancy specific. So in residential, we still require some level of smoke detection or smoke alarms in addition to the sprinkler protection. But what's the owner's objectives? Are they comfortable with allowing the fire to grow to a magnitude or size that would cause that sprinkler to operate? Or are they looking for some higher level protection? And that may get back to what we are protecting and what we are trying to protect the people, the property, what we're trying to protect them from.
All right. Thanks, Bill. Dave, we have time for just one more question, and this one's for you. What are your thoughts on a partial fire alarm system? So we're talking about a remodeled building. Perhaps only part of the smoke detection system is put in, but not in the other areas that are being remodeled. Are reviewers, how do you approach this as a reviewer?
Yeah, well, I think it's fine, but I'm going to preface that, right? I would start out with saying that most fire alarm systems are what we call partial systems, right? Most fire alarm systems don't cover the entire building, right? They may cover a space or a use or an occupancy in that specific building and not the other uses of the building. So it's a partial system when we look at it in that sense. Now, the big question that comes around is the owner, based on what Bill and I were talking about, has some goals that they want to have. They want, life safety or property protection, or really, that mission continuity, right? They want early detection and early notification or early response from the fire department. So they suffer less damage, right? And they can return or stay in business better, right? So the fact of the matter is that it's okay to install smoke detection in one part of the building or one part of the occupancy and not the other parts, right? It depends on those goals of what they're talking about, right? But where they're installing it, I have to go back to say that where they want that detection, it needs to comply with like NFPA 72 design requirements, right? You can't just stick a few devices up and expect it to function and operate as they think it would, right? It needs to have those design parameters, right? So it's either the prescriptive methods or they can justify some type of performance method for fewer detectors or more detectors or whatever it may be. It does need to comply. What is installed does need to comply with those design standards.
Okay, fantastic. Well, as we wrap this up, I'd like to thank you both. Dave Lowry, Bill Koffel, fantastic job. I really appreciate you sharing your time and expertise. And before we log off, we need your feedback to improve future sessions. A couple of questions will pop up on your screen as soon as this webcast ends, and please take a few seconds to answer them. Finally, on behalf of Consulting, Specifying Engineer, and CFE Media and Technology, thank you and goodbye.